Hi everyone, welcome back to another video in our Ethereum series. In this video, we'll dive deeper into Ether. So before we talk more about Ether, let's try to understand what is a cryptocurrency first. So a cryptocurrency sets the incentive design between various network participants, and it's sort of a medium of exchange between these participants that is secured by a blockchain based ledger. There are multiple examples of cryptocurrencies like Bitcoin, Ethereum, Dot, Solana, Filecoin, etc. But since we are talking about some network here, let's try to understand what kind of network is it. So to get a better understanding of what kind of networks we are talking about here, you have to understand the concept of two-sided online marketplaces first. It is a very simple concept, which is that a two-sided online marketplace is sort of a platform where some kind of service providers come and provide their services, and then users come on this platform to consume those services. You'll see examples of this all around you. Most of the services that we use today are some sort of two-sided online marketplaces. You can talk about Uber, Amazon, etc. All of these are similar in nature, in the sense that some kind of buyers are on Amazon to buy some product and some sellers are there to sell their products. Similarly, with Uber, the cab drivers are there to provide taxi services, and the ride hailers are there to book a ride and travel from one point to another. So these are the example of two-sided marketplaces, and currently these two-sided marketplaces are being operated by centralized entities like Uber, Amazon, or Instacart, etc. But with blockchains, this centralized entity is replaced with a distributed network of nodes. So ultimately, it becomes a network that is running some kind of protocol, for example, Ethereum, and the protocol sets some kind of incentive design and some kind of baseline properties. For example, with Ethereum, you can write and upload smart contracts on it, and you can also have accounts. So you can create some kind of financial applications that you can execute on Ethereum. Similarly, on Filecoin, you can have some data storage operators which will store your data for you, and this is done in a completely decentralized and permissionless way with no authority controlling it in any way. For this network to be able to sustain itself, it should have some kind of incentive design that will bring in these service providers on the network and make the network usable for the users. If a user is not able to do something with the network, get some value out of it, the network is useless. So there has to be an incentive design in place on the network so that the providers can join the network and provide services to these users. And when a transaction of this service is happening between a service provider and a service user, there has to be a medium of exchange between them also. And this medium of exchange is our cryptocurrency. So coming back to the cryptocurrency, cryptocurrency is a medium of exchange that is anything widely acceptable as a payment for goods and services. These goods and services can be of nature that I just explained, like data storage or computation. And all of these transactions of goods and services will be happening on the blockchain. So, blockchain essentially becomes a ledger to keep a track of all of these transactions, and it allows the users to make transactions on this ledger without relying upon any centralized authority or a trusted third party to maintain the ledger. So, now that you understand what a cryptocurrency is from the first principles, you can already understand what Ether is exactly here. Ether is the native cryptocurrency that sets the incentives of the Ethereum network. It creates a market for computational resources on the Ethereum network. The nodes of the Ethereum network, the miners or validators, provide their resources for doing computations, that is, maintaining the EVM state and updating it. And a user pays them in the form of gas fee, which is denominated in Ether. So a user pays Ether for doing a transaction on a network, and a node receives Ether for processing the transactions. A node also receives Ether in the form of minting rewards for participating in the network, which is basically validating and adding new blocks to the network. In order to participate in the process of validating and adding blocks to the network, the node first needs to stake some Ether as collateral on the network. This is done so that the node doesn't act in any malicious way, because if they have a collateral logged on the network, which is 32 ETH at the moment, and they are found to be doing something fishy, all of that collateral is slashed to zero. So this is just there to add some skin in the game aspect for the nodes who are maintaining the network. If they do anything that is not in favor of the network, their collateral will be slashed and they'll suffer a monetary loss because of it. So I just explained how Ether is used as a medium of exchange on Ethereum. Let's use Etherscan to see that in real time. Here we have the homepage of Etherscan, and on the left side you will see all of the latest blocks that have been added to the network. And on the right side you will see all of the latest transactions that have been added to the network. So as I mentioned, a block will contain multiple transactions. This block contains 159 transactions, and all of these transactions are of type that A sent something to B, and there's some value associated with it and a transaction fee in proportion to the computation that is required by that transaction. And once you go deeper into a transaction, you'll see all of the details about it. Like this transaction was sent from this account to this account, and the value that was associated with this transaction was 0.003 Ether, and there was this transaction fee, and the gas price at the time of this transaction was 8.199. We'll talk more about gas price in a later video, but this is how you can check out all of the details about a transaction. Going back on the block, this was the block that we referred to earlier. You can see all of the details here, that what was its time stamped, uh, the number of transactions, the number of withdrawals, who was the fee recipient, that is the node that got the fee for adding this block, the block reward has static block reward, transaction fee, and burnt fee. So for every block you have one static block reward given by the Ethereum protocol to the node that has added the block. This is at the moment 2 Ether. I don't know why it's showing 0 here. There must be some kind of bug. But for producing a block, the block minting reward is 2 Ether that is given to every block producer. And apart from that, a tip from all of the transaction fee also goes to the block producer. And the base fee of every transaction is burned in the network. Now we'll try to answer the question, how does new Ether enter into the network? So it enters via process called minting. Ether is created by the Ethereum protocol, and a user cannot create new amount of Ether. Ether is minted as a reward for each block proposed at every epoch checkpoint for other validator activity related to reaching consensus. So Ether is minted as a reward for each block proposed and also at every epoch checkpoint for other validator activity related to reaching consensus. So if you recall that whenever a new block needs to be added, it is propagated throughout the network, and each of the node of the network verifies and validates the block and approves it. So for participating in that process, each of the node involved also gets rewarded in the form of Ether, which is the fraction of the total amount of new Ether minted on the protocol for adding a block. So the total amount issued depends on the number of validators and how much Ether they have staked. As I mentioned earlier, there's a minimum deposit of 32 Ether required for each node to participate in the block validating and producing mechanism. And the total amount issued depends on the overall amount of Ether that has been staked collectively by all of the validators in the network. The total issued amount is divided among these validators based on their performance. About 1/8 of the total issuance goes to the block proposer, that is the node that has proposed a block to be included on the network, and the remaining portion is distributed among other validators. The node that has proposed the block to be added to the blockchain also receive tips from the transaction fees and some MEV related income, but this is not new ether. This is the ether that is already there in the accounts of the users, and they're just giving it away to the block producers or the Ethereum nodes to prioritize their own transactions. So we talked about adding new ether to the network. There's also a process called burning where ether is removed from the circulating supply permanently. This also occurs on every transaction on Ethereum. Whenever users pay for their transaction, the transaction fee is divided into two parts, a base fee and a priority fee. So the base fee of the transaction that is set by the network according to the demand of the network is destroyed in the process. So, as I mentioned about minting and burning of Ether, we'll refer back to the same block that we were talking about earlier, and you'll see that it has a block reward associated with it. The static block reward should be around 2 ETH, but there's some bug here. But you'll see that some transaction fee was also added, and this was the priority transaction fee. The burned fee is an accumulation of all the base transaction fee covered in this block. Since we are talking about burning and minting of Ether, you can also check out this cool website called ultrasound.money that has all of these dashboards and metrics related to minting and burning of Ether. You can see in the past 7 days what was the burn rate, what was the supply growth, and what was the issuance of Ether. So, this is a very cool dashboard that you should definitely check out. Next is denominations of Ether. So, if you have covered a Solidity basics part, you will remember that Ether is denominated in Wei and Gwei. So, the value of many transactions on Ethereum are smaller than 1 ETH. You won't transfer in the multiple of 1 ETH every time. You can also transfer fractional amount of Ether. So Wei is the smallest possible amount of Ether and is generally used while referring to the technical implementations. And there's another unit called Gwei or Gigawei, which is mostly used for human readable gas fees. So one way is equal to 10 to the power minus 18 E. That is, there are 10 to the power 18 way in 1 ETH, and 1 gigaway is equal to 10 to the power minus 9 ETH. That is, there are 10 to the power 9 gigaway in 1 ETH. Now, each transaction on Ethereum contains a field called value, which specifies the amount of Ether to be transferred from one account to another, that is, from the sender's address to the recipient address. This value is denominated in Wei, the smallest possible amount that can be transferred on Ethereum network. When the receiver is a smart contract, this amount is often used to pay for the gas. So if you are calling a smart contract, the value you pass along with your transaction is used to pay for the gas fee needed for executing your transaction. So coming back to Etherscan, we'll check out a transaction. You'll see that this transaction happened from an account to a smart contract. You can go to these profiles and you'll see that this is address here. So this was an account and this was a smart contract. So a transaction happened from an account to a smart contract. Some ether was sent from the account to the smart contract, and there was some transaction fee for processing this transaction. Users can also query the ether balance of any account by looking at the account's balance field. This balance field shows the ether holdings denominated in Wei, which is the smallest possible unit on Ethereum network. So again, we'll take this transaction and we'll go to this account, and you'll see that you are able to see an ETH balance here. In the raw form, it's represented in Wei. Here, since we are using a UI, it's much more readable. In its raw form, this is stored as a UINT 256 value. That is the total number of Wei being held by that account. So that was all about Ether. Next, we'll look into dApps.